Good afternoon, everyone. It's just a pleasure to have here today in our Abralim ao Vivo Linguistics Online, Jeffrey Leeds. So I'm just going to give a short introduction about all his work and the importance he has for us here in Brazil, and I'm sure for around the world. So Jeffrey is a professor of linguistics at the University of Maryland. He directs the project Children's Language Learning and in the Infant and Child Studies Consortium. He's also on the executive committee of the Maryland Language Science Center and the Neuroscience of Cognitive Science program. Jeffrey is also the editor-in-chief of the Journal of Language Acquisition, a journal of developmental linguistics, which is quite important for us here in Brazil. So welcome, Jeffrey. And so the stage is yours.
Hi. Let me share my screen. Hold on. Okay. Great. Well, thank you for inviting me to join you here today. I wish we were living in times when an in-person visit to Brazil were possible. I am thinking about all my friends and colleagues in Brazil and hoping that everyone does their best to stay safe and healthy. And I hope that this talk will provide some small relief from the pandemic. So let's get started. Let's begin with an idea that should be familiar to just about anybody who's studied linguistics, though some people have a wide variety of views about this idea. And the idea is about the existence of a language acquisition device inside the mind of children. And the idea goes something like this, that adults have grammars inside their heads, and those grammars produce sentences. Those sentences provide the input to a language acquisition device, and out comes a child grammar. And we as scientists are able to detect the properties of the child's grammar by examining the sentences that they produce, acceptability judgments that they make, other kinds of behaviors, whatever clever things developmentalists can figure out to get kids to reveal what they know. And whenever we see a kind of a mismatch between the sentences that go in to the language acquisition device and the kinds of grammars that come out, then that gives us some evidence about the structure of the learning device. So let me give an example. So the argument for the existence of a non-trivial language acquisition device was based on arguments from the poverty of the stimulus, the idea that the data that learners are exposed to are compatible with wide ranges of generalizations, but learners nonetheless converge to a surprising degree on the same grammar. So for example, let's take this case. Sally knows which picture of herself Janie put up. So in this context, we can interpret this reflexive pronoun as being bound by Sally. So it can mean that Sally knows which picture of herself, Sally, that Janie put up, or we can interpret that as referring to Janie. Sally knows which picture of Janie put up. However, when the WH phrase is a predicate, so Sally knows how proud of herself Janie was, then we only get the interpretation that Janie was proud of herself and not Sally. Now, we can imagine all kinds of generalizations that are compatible with the input. And in this case, the input is particularly silent. So, so speech to children includes essentially no examples of reflexives contained inside WH phrases. So whatever they know about reflexives inside WH phrases is a kind of projection beyond their experience. And you can imagine projecting in a way, say, that treated these two things alike, either in allowing both possible antecedents for a reflexive contained inside the WH phrase, or neither, only allowing Janie in both cases. But that's not what we see. We see instead this split. And that kind of split, which seems to be in place as young as 4 years old, indicates that there's something that the learner is providing beyond what's in the input that determines how they generalize. And so, so this has been the kind of standard argument for the existence of a language acquisition device that has some kind of immanent structure in it. And that has been extremely useful for identifying the structure contributed by the learner when thinking about language acquisition, but it abstracts away from two important features of child development. One, development. It doesn't give us a model in any sense of like what happens from moment to moment, from week to week, year to year, in the acquisition of language. And it abstracts away from the perceptual capacities of the child, which are surely changing over time. So let's take a kind of trivial example. So let's take a simple case like the sentence, "Which toys did you bring?" If we have a little tiny baby like this, then maybe at best they're just representing that as a sound wave. They're not able to identify the words, much less the syntactic structure. And as that child gets older, we might find that she can maybe represent the fact that the bring is a verb and that it has a subject, but not really know how to incorporate the WH phrase into the structure. And then maybe sometime later they figure out that, oh, I see the WH phrase is serving the role of the object of the verb. So, so the child's perception of their environment is changing as a function of what they know at any given time in development. So what I want to do today is kind of look inside the language acquisition device in order to see how we can incorporate the child's changing perceptions of her environment into a theory of how grammars are acquired. So inside the language acquisition device, we have a bunch of, let's say, components. So here's the idea. So here we have above this line is what's happening external to the child, and below the line is what's happening internal to the child. We have input. Those are the sentences that are produced by adults. And we have some method of encoding that input. And that encoding is going to be based in part on the child's grammar, in part on various kinds of parsing procedures, and all kinds of extralinguistic systems: audition, pattern recognition, memory, theory of mind, conflict management, all kinds of stuff that it's just a part of cognition. And that's going to yield a perceptual intake representation. So some kind of a linguistic representation of that input, which may be only partial. That intake representation will feed forward through to behavior. So production systems is just a kind of catch-all term for anything that is involved in child behavior. And so when we're studying child's behavior, what we're seeing is something that's based on the child's intake, that is their perception of the linguistic signal, which will be fed by these kinds of encoding mechanisms. That perceptual intake, in addition to feeding behavior, will also feed into a kind of inference engine, the thing that does the learning. This is the kind of place where the traditional language acquisition devices structure lives. So here we have something like universal grammar, whatever the kind of core knowledge constraints with respect to language there are that shapes the way grammars come out. And that's going to lead to a kind of further shrinking of the intake. So the child is going to select those features of the perceptual intake that are relevant for making some decision about some grammatical feature. And that's then going to feed forward to some conclusion about the developing grammar. That new knowledge in the developing grammar will then be part of what's involved in encoding future sentences. Okay, so that's the kind of the basic sketch of how we think the language acquisition device functions. Okay, so we're going to kind of focus on two halves of the language acquisition device here. So this left half of that model, we're going to focus on what's involved in perceptual encoding. I'll show you how and why the perceptual intake changes over the course of development. And then we'll focus on the learning function, that is this inference engine, and how the perceptual intake is subject to further filtering in the acquisition of a grammar. Okay. Empirically, we're going to focus on two kinds of dependencies. So local dependencies, the argument structure dependencies. So cases like, you have some verbs that are transitive, some verbs that are intransitive. So in this case, you have the verb bring, which is transitive. We can tell because it requires a noun phrase to its right. So when you say April is bringing the toy, that's okay, but April is bringing is not. So that that's a local dependency. It says bring says I need a noun phrase to my right. In addition, we're going to look at long distance dependencies. So cases like what is April bringing here is kind of interesting. So the requirement that bring has a noun phrase to its right is lifted just in case we have a WH phrase somewhere at the edge of the clause. So what is April bringing is possible. And when we say, what is April bringing the toy, that's not possible. So that tells us that the WH phrase is kind of filling the same role as the noun phrase to the right of the verb. So how is it that children are able to discover that WH phrases play that role of filling argument relations that are required by the verb? And there's a kind of an interesting learning puzzle here, which is that argument structure seems to be hidden by WH movement exactly this way. When you hear what is April bringing, if you didn't know that the WH phrase was an argument of the verb, then you might think that bring is intransitive incorrectly. And so we can ask, like, what are the consequences of the fact that movement operations hide argument structure properties of verbs? In addition, movement properties depend on argument structure. We have movement relations only, we have argument movement relations just in case we have arguments to move. So, so there seems to be a kind of an interesting chicken and egg problem that we'll get to in more detail a little bit later. But first, let's just focus on the local dependencies, local argument dependencies. And so what I'm going to show you is two basic things. First, that clausal argument structure is in place by 16 months. That is, children know the relation between argument positions and thematic relations by 16 months. And lexical argument structure is kind of laid on top of that, can be used predictively for the purposes of understanding as the child's vocabulary grows, but that can lead to some misperceptions of their input. Then we'll see that long distance dependencies like WH movement are acquired later, so by 18 months, and that those can be used to feed predictive parsing as young as 19 to 20 months. And then we'll talk about the learning problem. So once we've established the relative order of acquisition of local dependencies and long distance dependencies, we'll think about learning, and we'll see a mechanism by which learners filter the data to kind of abstract away from the consequences of movement when learning argument structure, and then in learning, then how they use the argument structure to identify the surface features of WH movement. So that's kind of an overall roadmap of where we're going. So one thing that we know is that children know a lot about local dependencies by roughly their second birthday. So for example, if we show children two videos side by side of, say, this boy is doing something to this girl, pulling her around on a chair using some kind of a tool, and in this video, the girl is pushing the boy up and down, what we see is that if you say the sentence, the girl is gorping the boy, then children will focus their attention on the image in which the girl is the agent and the boy is the patient. And if we say the boy is gorping the girl, then they will focus their attention on the event in which the boy is the agent and the girl is the patient. Again, so gorp is a novel verb, so their ability to do that seems to depend on knowledge of the relation between syntactic position and thematic relation. We also know that 2-year-olds will interpret verbs in a transitive clause as a label for a causal action. So for example, in this study, two people are having a conversation and they use a novel verb over and over again. In one dialogue, they're using the verb transitively. In the other dialogue, they're using the verb intransitively. And what we find is that those kids who heard that novel verb in a transitive clause, when later asked to find an event that exhibits that verb, they choose the 2-participant test event, the one where somebody is pulling on somebody else, doing something to them, not the 1-participant. And we don't see any difference in the intransitive case. Now, in order to do that, either of these two things, the child has to know something about the links between thematic relation and syntactic position, and to use that knowledge as a cue for identifying the meanings of verbs. Okay, so our question really is, when is that knowledge acquired? When do they know that syntactic position and thematic relation are related and how they're related? Okay, so so let's consider a case. So here we have a sentence, he's pushing with the GOP. in that case, we don't know what GOP means, but we do know that whatever a GOP is, it's the instrument of a pushing. So if we were to then look out into the world to find a GOP, we would know that it's the thing that's used as the instrument of the pushing. And if we hear a different sentence, he's pushing the GOP, then we would take the GOP to refer to the thing being pushed, the patient of the pushing. Okay, so Aaron and White and I asked essentially, when do babies know about these relations, about the difference between being a direct object versus being a prepositional object, the consequences for interpretation. So I'm going to show you an example of what this video looks like.
Hey, look at that! She's pushing with the GOP. Wow, do you see her pushing with the GOP? Yay, she's pushing with the GOP. Where is the GOP? Which one is the GOP?
Okay, so if you were paying attention, whoops, you would think that the GOP is the thing being pushed. Sorry, is the thing being used to push. He's pushing with the GOP, so the truck in that case. So similar case, we show videos of somebody wiping a camera with a cloth. We say she's wiping with the TIG, so same structure, right? And now here, what would you have to do to get this right? So you would say, represent this syntactic structure where the PP is contained inside the VP, it's an adjunct, and you then use the syntactic position of the novel word to assign it the thematic relation. It's the instrument because it's the object of with. And so then you would say, well, in that event that I'm seeing, the instrument is the cloth, and so TIG means cloth. And so when asked which one's the TIG, you should then choose the cloth. Okay. On the other hand, some kids heard a sentence like she's wiping the TIG. So same video, but with different audio. She's wiping the TIG. Do you see her wiping the TIG? Okay, so in that case, you take the TIG to be the direct object of wipe. And so we have a wiping event with an agent and a patient. The patient is the thing in the direct object position, and so the TIG. And in that case, then the thing being wiped, the patient of the wiping, is the camera. And so children should choose the camera in that case. Okay, so here's what this data looks like. Let's look at the 16-month-old data first. So this is a control condition where during that same familiarization video, we just say it's a TIG. Do you see the TIG? So there's no information in the sentence about what the right answer should be. That gives us a baseline. And what we see is that the kids who heard she's wiping the TIG, they look more towards the camera. And the kids who heard she's wiping with the TIG, they look more towards the cloth. So we see this interesting asymmetry. At 16 months, they seem to know that the direct object, a noun phrase in direct object position should be the patient of the event, and a noun phrase in a prepositional object position should be, in this case, or the object of with should be the instrument in that case. And interestingly, what we see is that 19-month-olds don't show that same pattern. So at 60 months, we see the effect of syntactic structure on interpretation, but at 19 months, that effect goes away. If we now look at these kids more closely and we ask, well, what do they do as a function of as their vocabulary grows? So as their vocabulary grows between 16 and 19 months, what we see is that the children with larger vocabularies show less of an effect of syntactic structure. So as their vocabulary grows, they tend to think that well, exactly what this shows, as their vocabulary grows, their interpretation of the object of the preposition becomes more like their interpretation of the object of the verb. Okay, so that's a strange pattern. So what we see is that 16-month-olds, or especially at the lower vocabulary end of that range, show a knowledge of the link between syntactic position and thematic relation. However, at 19 months, they seem to get worse. So what's responsible for that them getting worse. And our idea about that, our first hypothesis about this, was that that's interference from new knowledge in the form of the lexical properties of the verb, plus a predictive parsing mechanism which feeds their perceptual intake. So our question basically is, how does the accumulation of a verb lexicon impact syntactic inference? Why is it that as the child's verb vocabulary grows, their ability to use syntax as a cue to meaning gets worse? Okay. So first we looked at the verbs in our study and asked how often are they used in a simple transitive VP with a direct object and a prepositional phrase, or with just a prepositional phrase. So intransitively, but with a prepositional phrase, or intransitively with a prepositional phrase headed by with. And what we see is that the vast majority of the time they're used in simple transitive clauses, and very rarely are they used in intransitive clauses with prepositional adjuncts. Moreover, if we look across the entire verb lexicon, so here's the lexicon ordered by frequency. So high frequency verbs on the right, low frequency verbs on the left. And what we're plotting here is the ratio of sentences in child-directed speech where you have a direct object versus ones where you have no direct object, but you have a with PP. And what we see is that as we go from more frequent to less frequent, this ratio basically settles at never always above 10 to 1. So it's always 10 times more likely for any verb that it's going to take a direct object and not occur intransitively with a prepositional phrase. That is any verb that allows these kind of subcategorizations. Okay, so our idea then is that this distributional bias, that is this fact about the way verbs distribute in speech to children, licenses a kind of syntactic prediction. That is, children expect when these verbs are used, that they're expecting to hear a direct object. And what happens is the child relies on that predicted structure over the actual string that was presented to them. So let me just spell this out a little bit. So the child has gotten this far. So they're hearing the sentence, he's wiping with the TIG. So they've gotten to he's, they've built a certain amount of syntactic structure based on what they know about their grammar. They hear wiping, they say, I know wipe. Wipe is the kind of verb that occurs with a direct object. Then the sentence comes in with the TIG, right? And now they have a kind of a conflict between what's in the signal with the TIG and the structure that they've already built in anticipation, having heard the verb wipe. And so the idea is that that predicted structure kind of wins out. And so the preposition is unable to be incorporated into the sentence, and the child ends up with a representation of the sentence, even though they heard he's wiping with the TIG, what they represented was simply he's wiping the TIG because they were unable to incorporate the preposition into the structure. As a result, they have a final parse with no preposition in it, and that's going to lead to an erroneous assignment of thematic relations and hence an erroneous interpretation. So they hear she's wiping with the TIG, they build a representation in which wipe takes a direct object, they don't incorporate the preposition into their representation, and so they end up treating the TIG as though it was the direct object, assigning it the patient relation, and hence think that it refers to the camera. Now, that's kind of a hairy story. So we need to see if it's true. So how are we going to test that? Well, we thought there were two predictions of this story, and the predictions are kind of symmetrical. So first, if we could somehow satisfy the transitivity prediction of the verb, then that would lead to the correct parse, and then the 19-month-olds would correctly interpret the TIG as the instrument. And the second prediction is kind of the converse of that, is that if we remove the transitivity prediction, if we could somehow take that prediction away, then that would lead to the correct parse. It would lead to the kids with larger vocabularies, the 19-month-olds, behaving like the kids with the smaller vocabularies, the 16-month-olds. So, so let's think about how we're going to do that. So the first prediction, if we satisfy the transitivity prediction, that should lead to the correct parse and hence the correct interpretation. So when we say something like she's wiping that thing with the TIG, now we've satisfied wipe's requirement that it take a noun phrase, direct object, and so that thing can satisfy that role, and then with the TIG can be incorporated into the structure correctly. So you'd end up with a string, a structure something like this. She's wiping that thing with the TIG. And then, of course, in that case, the TIG would be syntactically represented correctly, and so assigned the appropriate thematic relation, and so the referent then would be correctly learned to be the cloth. Okay, and then we compared that to cases like she's wiping the TIG with that thing. So in that case, the TIG, it should correctly be interpreted as the camera. Okay, and so that's what we found. So here we have mean proportion of looks to instrument as before. So so up means they looked towards the cloth, down means they looked towards the camera. And what we see is they look more towards the camera when you say she's wiping the TIG with that thing, and they look more towards the cloth when you say she's wiping that thing with the camera. So having satisfied the verb's transitivity requirement, then the 19-month-old's knowledge of the relation between syntactic position and thematic relation comes back. Okay, so that was our first prediction. Second prediction is about removing the child's ability to predict a direct object. And so what would happen then if we use a novel verb in this case? So we say she's meeking with the TIG. So now we have a novel verb. The child doesn't know anything about that verb, doesn't know anything about its argument structure. And as a result, they should parse that sentence on the basis of the signal. That is the words that they actually hear. And so they should correctly parse that sentence as she's meeking with the TIG, assigning the TIG the instrument relation, and hence interpret it as the cloth. Okay, and so that's what we did. We compared two groups of 19-month-olds, ones who heard he's meeking with the TIG, those who another group who heard he's meeking the TIG. And again, we see this asymmetry. So when we ask how often did they look towards the instrument, we see they look more towards the instrument if they heard he's meeking with the TIG, and more towards the patient if they heard he's meeking the TIG. So these 19-month-olds, notice, right, this is kind of cool. They're doing something better when they don't know more words in the sentence. So when you have a kind of Jabberwocky speech where they can't make any predictions on the basis of the verb, then they can interpret the sentence correctly. They can get apply their rules for mapping syntactic position to thematic relation. Okay. So let's kind of think about this with respect to the model that we've seen. So we have, let's say, one group of kids, we'll call them low vocabulary 16-month-olds, right? So we have, they hear she's wiping with the TIG. These children have in their grammar some knowledge of phrase structure and some knowledge of how thematic position and syntactic position and thematic relation relate to each other. They have a parser, and they end up with a veridical syntactic representation, one where the PP is an adjunct to wipe, and so they interpret the TIG as the instrument, and so that gets them to look at the cloth. As their vocabulary grows, however, so now we have higher vocabulary 16-month-olds, 19-month-olds, what we see is that they have additional information that they know about. They know about lexical subcategories. They know, for example, that verbs like wipe require a direct object. So they can use that information to make predictions as they're parsing. And now extra linguistic systems of cognitive control come into play, because now you have a conflict between the signal and the structure that the child has built sort of mid-sentence, right? And that conflict is difficult for them to resolve. And as a result, what we've seen is that they basically ignore the preposition, and they end up parsing that sentence as she's wiping the TIG, treating the TIG as the direct object, and hence they get the wrong answer looking at the camera. So, so as they get more knowledge about the grammar, in this case, lexical subcategories, that impacts the way that they're able to make predictions. That's going to interact with their executive function abilities, and that's going to lead to errors in interpretation. Okay, and as they get older, say by 28 months, I didn't show you this data, but it's true, by 28 months, they do the correct thing independent of what they know about the verb. And so that means that by 28 months, they're able to resolve that cue conflict more effectively. Okay. So what we've seen about local dependencies is that clausal argument structure, knowledge of the mapping between syntactic position and thematic relation, is in place by 16 months. As the child's vocabulary grows, they're able to use lexical argument structure, what they know about any particular verb's argument structure requirements predictively. They can use that information predictively, which can then lead them to distort what they perceive, and that can feed forward to errors, in this case, in word learning. Okay, so we see this interaction between the perceptual intake mechanisms and what the child knows at any given point. Okay, in this case, the intake mechanisms can hide what they know about the grammar. Okay, now we're going to turn our attention to long distance dependencies, WH movement. Okay, so a number of studies have looked at WH dependencies in kids between 15 and 20 months. And so here's an example of one of them. So here is, I'm not going to show you a video, but stills from the video. So you have a scene in which you have a white dog, a cat, and a brown dog. And first, the white dog bumps into the cat. Then the cat bumps into the dog. Cat bumps into the brown dog, and then and then the two dogs appear on the screen, and we ask the child either which dog did the cat bump, or find the dog that the cat bumped. Or we might say which dog bumped the cat, or find the dog that bumped the cat. So we have subject questions and object questions, subject relatives, object relatives, and we looked at 20-month-olds and at 15 months. 15-month-olds. And what we see is that the 15-month-olds do the correct thing in all four conditions. They get the right answer in the subject questions, the object questions, the subject relatives, and the object relatives. 20-month-olds, however, get worse. So again, we're seeing this kind of discontinuous development where kids get worse as they get older. So they do okay on the WH questions, but they seem to fail on the relative clauses. Okay. So the fact that the 20-month-olds get worse, is a reason to maybe be skeptical of the success that we see in the 15-month-olds. Okay. So especially when we think about what else babies can't do at 15 months, we get even more skeptical. So some non-adjacent dependencies, like the relation between is and the progressive ing, are not established until 18 months. WH questions don't appear in children's production until around 20 months. So it seems like a 5-month delay between comprehension and production seems like kind of a long time. Struggles with object questions and object relative clauses persist into the school years. And so, so all that leads us to be a little bit skeptical about this success. But worse, infants could cheat in this task to get to the right behavior. And let me explain how. So imagine that the child only is able to represent the local argument structure relations of the verb. So they hear which dog did the cat bump, but because they have limited grammatical knowledge, they're able to only represent the cat bumped and nothing else. And then they could use their argument structure knowledge to kind of fill in what was the point of the question, right? So they say, well, the cat bumped. Now you have this image of these two things. Say, well, the cat bumped one of these guys. Yeah, it was the brown one. And so in fact, the child can get to the right interpretation or the right behavior looking at the brown dog without actually parsing the sentence in all of its complexity. And of course, if that were true, the only children who should be able to do that should be the ones who know something about the argument structure of the verb. So we predicted then that performance in this task should depend on verb knowledge and therefore vocabulary. So how big a vocabulary you have should make you able to succeed at this task. So we tested 64 15-month-olds, again, in these four conditions with subject questions, subject relatives, and object relatives. And so in this case, the babies saw, say, a monkey feeding a frog, a brown monkey feeding a frog. Then they saw a frog feeding a black monkey. Then they saw the two events simultaneously, the brown monkey feeding the frog feeding the black monkey. And then they were asked one of these questions, which monkey is feeding the frog, which monkey is the frog feeding, etc. Right? And then what we see is, in accord with our predictions, that as vocabulary grows up, looks to the target also go up. So in both WH questions and relative clauses for both subject and object questions and relatives. Okay. So here, the vocabulary is helping you. That is, they're helping the child succeed at this task, but for exactly the same reason that having a higher vocabulary hurt you in the first experiments. So knowing about argument structure is helpful here to get you to the right interpretation. Knowing about lexical argument structure in the first study with prepositional phrases, right? That was what caused you to fail, but it's the same knowledge. Okay, so So our results are, let's say, consistent with that strategy of faking their interpretation of WH questions at 15 months, leading to the possibility that they can use what they know about verbs to infer what to do in these kinds of comprehension tasks without fully parsing the WH dependency. And that's plausible given other evidence of argument structure knowledge at this age. In fact, the evidence that I showed you earlier. But we would really need a more direct test because after all, you can't reason from the vocabulary effect to this particular hypothesis. Vocabulary is correlated with many capacities in infancy. So a vocabulary effect is consistent with many accounts of children's behavior. But again, we think this hypothesis is particularly plausible given what we know about infants' syntactic abilities at this age. So what we really want is a better test. How can we test for knowledge of the WH dependency without relying on interpretation, given that you can get to the interpretation in this kind of roundabout way? And so we thought about that for a little while, and we decided that the way to do it is basically the same way you would do it if you were making acceptability judgments. You would look for complementarity between the WH phrase and the postverbal noun phrase. So let's say if we have a case of declaratives, the cat should hug him. You have a verb hug, which requires a subject and object. And if you say the cat should hug, well, now that is violated. And so you expect, a difference there in the judgment. And when we give interrogatives, which dog should the cat hug him? Now the presence of the object is ungrammatical because that role is filled by the WH phrase, but which dog should the cat hug is good. So what we want is a kind of way to get acceptability judgments for these kinds of sentences from babies. So how can we detect that whether babies are aware of this complementarity between the WH phrase and the direct object noun phrase? Okay, so now thinking about our hypotheses, so suppose they represented an argument structure, but not the WH dependency. Then what you would expect is that you'd see the same pattern of judgments, again, assuming we know how to get them. For declaratives, you should show a difference here. They should like the one with a direct object and not like the one without the direct object. And they show that same pattern in the interrogatives if they don't realize that the WH phrase is filling that role. And so they should like the one where hug takes a direct object and not like the one where hug doesn't take a direct object. So that's if our hypothesis is about 15-month-olds is right. We should see the same pattern in 15-month-olds for declaratives and interrogatives. And then as they get older, if they represent both the argument structure and the WH phrase, that WH relation, then what we should see is opposite patterns. They should like the case where the hug takes a direct object when it's a declarative, not like the one when it doesn't. And in the interrogative, it should flip. When you have a WH question, the object should be judged to be unacceptable, and the case without the object should be judged as better. Now, how can we get acceptability judgments from babies? So now we're not asking for interpretation, we're asking for acceptability judgments. Anybody who's ever asked like a 4-year-old for acceptability judgments knows that it's really hard. How are we going to get this kind of data from 15-month-olds? So here, Laurel Perkins developed a kind of ingenious idea. This was what we call a sequential listening preference procedure. So what happens in this study is the child sees some abstract shapes on a video screen. And while they see that, some sentences are playing. For example, hey, which dog should the cat hug? Ooh, which bug should the giraffe tickle, etc. So these are WH questions, but they'd be all kinds of different things depending on condition. If the child looks away for 2 seconds, the audio stops and the attention getter comes up on the screen. And when they look back to the attention getter, the interesting video returns and the sentences resume. Okay, and we just ask like how do they like listening to these sentences when they have WH questions or declarative clauses. Okay, so what we manipulated here was declarative sentences versus WH questions and whether there was an object, an NP after the verb or not after the verb. So in the declarative case, you have something like a dog. Which dog should the cat hug? So you have the verb without a direct object in the declarative where it's ungrammatical, in the WH question where it's grammatical, right? And then in the case where there's a direct object, we have a dog, the cat should hug him, or which dog should the cat hug him? So here again, you have the case where it's grammatical in the declarative with the direct object, ungrammatical in the WH question with the direct object. Okay, what we're going to measure is how much do they listen to the sentences with direct objects compared to those without. Okay, so here's the video of a baby doing this task.
Ooh, which dog should the monkey hit her? Wow, which goose should the mouse cover him? Hey, which cow should the elephant bump him? Wow, which cat should the bunny hug her? Ooh, which bear should the dog tickle him?
Okay, so you get the idea. So the babies just look at the screen while these sentences are playing. We just measure, do they have a preference for the sentences with direct objects versus without? Okay, so here's the data from the 15-month-old. So what we're plotting here is the difference in looking time to the sentences with direct objects versus those without. So up means they listen more to sentences with direct objects. Down mean they listen more to sentences without direct objects. 0 means they listen equally to both. What we see is an overall preference in the 15-month-olds to listen to sentences with the verb followed by no direct object. And we see that same pattern for both declarative and WH questions. Okay, so that is they listen preferentially to the, in this case, the sentences that the verb's local argument requirements are not satisfied. Okay. When we turn to 18-month-olds, what we see is an opposite pattern. So in the 18-month-olds, what we see is in the declaratives, they listen more to the sentences that have direct objects. So that is, they listen to the grammatical declaratives. And in the WH questions, they listen more to the sentences without direct objects. So that's to say they listen longer to the grammatical ones. So we do have, in fact, a kind of acceptability judgment in the form of how long were they willing to listen to these sentences in the case of 18-month-olds. So the 15-month-olds show no asymmetry between declaratives and WH questions. The 18-month-olds do show an asymmetry. So we're catching the acquisition of WH movement right there. Okay, so 18-month-olds register the complementarity between WH phrase and a post-verbal noun phrase, and therefore represent the dependency between the WH phrase and the argument taking requirements of the verb. 50-month-olds, however, don't, right? But they do notice violations of the local argument dependency, suggesting that their earlier success in the interpretation tasks was actually based on the argument structure properties of the verb and not based on a syntactic representation of the WH dependency. Okay, so here's what we know so far. So when it comes to WH questions, long distance dependencies, we see that they're acquired by 18 months. Earlier successes are, according to us anyway, only apparent. And so now we can ask about, well, how is this information used online, like for the purposes of perceiving sentences? So remember this phenomenon that we talked about earlier. You had sentences like she's wiping with the TIG, and children with at 19 months who knew lots of verbs would expect that a verb would take a direct object and consequently miss the preposition and interpret the TIG as the patient of the verb and hence the camera in this scenario, right? So that we saw earlier. And we saw that if you could satisfy the transitivity properties of the verb, so in this case, say she's wiping that thing with the TIG, then their knowledge of the content of the prepositional phrase would reemerge. In that case, we say she's wiping that thing with the TIG, they would interpret the TIG as the cloth. Okay, so now our question is, what happens in a WH question? Can the child incrementally take the WH phrase as satisfying the property, the requirement that the verb takes an object, in which case it should allow the prepositional phrase to be interpreted correctly? Okay, so if the child is able to use what they know about WH questions and what they know about verbs to take that WH phrase to satisfy the verb's requirement, then they should interpret the prepositional phrase correctly. Okay, so again, the string wiping with the TIG will be present in both the kind of declarative condition and the WH condition, but it's only in the WH condition that the children are predicted to succeed. Know the and the verb. Okay, so if 19-month-olds process the WH questions incrementally, then they should not make the instrument error in the WH question. Okay, so so we compared sentences like she's wiping with the TIG to what is she wiping with the TIG, right? If they can integrate the WH phrase online, then we expect that they should interpret the TIG as referring to the cloth in that case, right? Of course, we know that 19-month-olds, she's wiping with the TIG, will interpret the TIG as the camera, and we're going to just replicate that effect, right? Now, if they can't integrate the WH phrase, so if they're not treating the WH phrase as satisfying the properties of the verb, then they're going to miss the direct object, and they're going to take wiping with the TIG the same way they would take it in the simple declarative. Okay, so incrementally processing non-local arguments should circumvent their parsing error, that is the error they make of losing the preposition. Okay, and that would then provide additional evidence for knowledge of the WH dependency at this age. So let's watch a baby doing this task.
Look at that! What is she wiping with the TIG? Wow, do you see what she's wiping with the TIG? Hey, what is she wiping with the TIG? Ooh, that's a nice TIG. Where's the TIG? Which one's the TIG?
Okay, so here's what our data looks like. So again, we have looks to the instrument here. On the y-axis, what we see is an overall bias to look in the beginning of the trial towards the camera, and we want to ask, does that bias dissipate in the WH question? So here we see that it doesn't. So that is in the simple intransitive, she's wiping with the TIG. Kids look more at the camera, they stay at the camera. But if you say, what is she wiping with the TIG? Then you see this big increase over time. So the blue is a replication of the 19-month-old effect, and the red shows that they're able to take the WH question, that WH phrase, as filling the argument roles of the verb. Okay, so the WH question stops the 19-month-olds from making this parsing error that they make in simple declaratives, which implies that they know something about the WH dependency, and it implies that their parser incorporates their new knowledge of WH phrases almost immediately after acquisition, right? Okay, so so let's again go back to our model, right? So we have when we're thinking about WH questions, non-local dependencies, we have high vocabulary 15-month-olds. If they hear a sentence like, which dog did the cat bump? They know something about grammar, thematic structure, they know something about lexical subcategories, like that bump is a transitive verb, and they're able to use that information to anticipate that there should be a direct object. And in this case, they end up with they don't know about the WH movement, as we've seen. And so what they end up with is the cat bumps, and they have this missing argument, and they're able to find an interpretation. So who's the thing that was bumped by the cat? Okay, they get the right interpretation, but not because they have the right parse. Okay, by 18 months, what we see is that in addition to that knowledge, they've also acquired knowledge of WH movement. And so they're able to incorporate this WH phrase into the representation. Okay, and then again, what we see is that in the case of what is she wiping with the TIG, they're able to avoid making a parsing error that they would have made otherwise by treating the WH as the direct object immediately upon encountering it. So that's telling us that in addition to knowing the grammar, they also seem to have a kind of active filling strategy. That is, when they hear the WH, they know they have to satisfy or find a verb that it's an argument of as quickly as possible. Okay, so we see in the case of long distance dependencies, WH movement, they're acquired by 18 months, and they're used in predictive parsing as early as 19 months, so 19 to 20 months, so almost right after acquisition. Okay, now we have a puzzle, the kind of final point of what I want to talk about, which is how children figure out the argument structure dependencies, especially given that there are so many WH questions and passives, topicalization, et cetera, in their input. So how can they identify the argument structure dependencies, given that there's lots of other stuff that can hide those argument structure dependencies in their input? And then second, how do they transition from only knowing local argument dependencies to also knowing these kind of long distance WH dependencies? Okay, so now we're going to focus on this kind of learning portion of our model. So what happens to the perceptual intake that allows the child to then make further inferences about the nature of the grammar? Okay, so what we know so far is that local dependencies, argument structure dependencies, are acquired before non-local dependencies like WH movement. Okay, so our first question is, how is it that lexical argument structure is acquired in the face of non-basic clauses with non-local dependencies in them? So let me kind of explain what I mean here. So we know that learners are able to draw inferences from, say, clause transitivity in order to learn verb meanings, right? And we know that they're able to identify the thematic dependence in a clause. Okay, now how do they do that? How do they acquire the lexical requirements of any given verb, right? So, and the thing to think about is this. So you have sentences like Sam ate a sandwich or April brought some toys. And eat is a verb that sometimes takes direct objects and sometimes doesn't. So you can say Sam ate a sandwich, Sam ate. Bring is a verb which takes direct objects obligatorily. So April brought some toys is good, April brought is bad. Now, what happens with sentences like 3 as a learner? So which sandwich did Sam eat? We interpret the sandwich as the direct object of eat, and which toys did April bring? We interpret the toys as which toys as the direct object of bring. But what stops the child from thinking that sentences in 3 are illustrations of the optionality of the direct object, and then learn that bring is an optionally transitive verb, and then make different inferences about its meaning, right? So in other words, in order to figure out the clause transitivity, you have to recognize the arguments in the clause. But we know that earlier in development, children don't recognize that the WH phrases function as arguments. So how is it that they're able to correctly learn, say, that bring is a transitive verb, given that they're going to hear lots of examples of bring being used in WH questions? So we have a kind of a chicken and egg problem here. If you knew that the WH phrases were arguments of the verb, then you would know that these were really transitive clauses. But you need to know that these are transitive clauses in order to figure out that these WH phrases are the arguments of the verb. And so we have a kind of a problem here, right? So one common idea in the acquisition literature is that the non-basic clauses, cases where you have transformations applying, stuff like WH movement, relative clauses, passives, topicalization, et cetera, those non-basic clauses need to be filtered from the data used for verb learning. So that is, if you just ignore all the cases that have WH movement in them, or relative clauses, passives, et cetera, if you just ignore those, then of course you'll get a good signal on the transitivity of the verbs. But how can you ignore them if you don't know what their structure is, right? It's not like these sentences come with a flag that say, hey, I have a transformation in me, right? Okay. So now one possibility is that maybe parents could do the filtering. Maybe the parents just don't use sentences that have these kinds of transformations in them. That doesn't seem to be true. So WH questions make up close to 25% of child-directed speech. So that means that kids are going to hear lots of examples of these kinds of sentences. Now, so the alternative then is that learners somehow do the filtering. They somehow know to ignore these sentences. But how can they know to ignore them? I mean, it's not, again, as I said, it's not like these sentences come with some kind of flag that allows the learner to say, hey, yeah, that's a non-basic clause. I can ignore that. So how do they do it? How do they learn the argument structure, given that the argument structure is hidden or distorted by various kinds of transformations in the language? Okay, so again, work of Laurel Perkins here. The idea that we had was to assume that some of the parses that the child hears are not trustworthy. And they can learn how to filter those non-trustworthy parses out from the data set without actually knowing why they're not trustworthy. Okay, so that's the hypothesis, that the child somehow figures out which sentences they can ignore, right? So when they hear a sentence like, which toys do you bring? And they can only assign a partial structure to it, one that treats bring as an intransitive verb, the child can ask themselves, do I trust that parse? Okay. And if they don't, they say, no, I don't trust it, then they can ignore that data point. So what would lead them to, how would they know which things to trust and which things not to trust? So here's the idea, that the learner can acquire the filter while they're also acquiring the transitivity. So the child hears sentences like, what did you bring? He's bringing cake. Did you bring your coat? Bring your blanket over here. Eat your peas. What are you eating? You already ate, etc. So they hear some huge distribution of sentences with these verbs in them, right? And if they consider everything that they hear as trustworthy, then they might learn that both eat and bring alternate between transitive and intransitive uses. And they would be right about eat and wrong about bring. If they filter out lots of sentences, well, then they're going to be left with the things which occur most frequently, like bring your coat, bring your blanket, eat your peas, and they'll learn that both verbs are transitive, which would be incorrect in the case of eat because eat alternates. If they can instead ignore just a little bit more of the data, then maybe they'll get the cases of bring that are transitive, and they'll get some alternators between eat and not. And so the trick is, how do you determine what's the threshold for ignoring? Okay. So here's the idea, is that the learner is asking them, so they collect up a whole bunch of sentences, right? And then they examine what they've got so far, the parses that they've gotten for those sentences. They ask themselves, how much noise is in this data? And that noise value could range anywhere from 0 to 100%. So there's so much noise that I shouldn't trust anything. That would be 100% noise, so don't learn anything from this. Or 0% noise would be, I'm going to trust every single thing I hear, and it could be anywhere in between there. And then what kinds of noise? In this case, like, do I hallucinate that there are objects in the clause, or do I imagine that objects are missing when they're actually there, right? Okay, so those are these two kind of sliders that the child is manipulating. And the idea is that, let's say we set the noise threshold at 20%, and we say that you're just as likely to have illusory objects or missing objects, and we have this distribution of input, then in this case, what we'll see is that they'll take 20% of the data out. And if they take this 20% of the data out, so 10% from the direct objects, 10% from the no direct objects as being noisy, then they'll get a much clearer signal on the transitivity properties of eat, bring, and in this case, wait. Okay. If, on the other hand, they set that threshold value of how much noise there is at 50%, well, then there's no way to kind of carve out 50% of this data that would give them a better signal than just taking all of the data. And so what the learning mechanism can do is kind of adjust these two sliders until it feels like it's got the best signal with respect to verb transitivity. Okay, so in this case, they can't do anything, so they say that's a bad setting, right? And you can just do that kind of iteratively, trying out different values for how much data to ignore and how much and what kind of data is produced by this noise function. And what we see is, so this is how a model like this performs. So it does pretty well. It gets about between 65 and 80% of transitive, intransitive, and alternating verbs. Total verbs, it gets about 66% of the transitivity categories correct. If we don't have a filter, then this learning model will get 70% of the verbs correct, but only because 70% of the verbs are alternators. So in other words, it gets all of the alternators right, and it gets none of the transitive or intransitive verbs right. And if we pre-specify how much noise there should be, our model does about as well as that. So we see that the model does better on intransitives and transitives than the baseline. So that tells us that the filter is necessary, and it's sufficient because it gets us to the right answer. Okay. Moreover, the filter can be learned from distributions in the data because it gets to basically the values more or less that it should get to. Okay. So learners are able to filter the data they're exposed to in order to learn local dependencies. That is, they don't take every sentence they hear as veridical, and they kind of estimate how much of this data should I trust And by manipulating that quantity, how much should I trust, they're able to get a clearer signal of basic categories like I'm a transitive verb, I'm an intransitive verb, I'm an alternating verb. Okay, now we can now turn to how that knowledge of argument structure. Now I've shown you how you can get to it in the face of WH questions and passives, relative clauses, etc. Right? Now having acquired that knowledge, how can it feed forward to help for the acquisition of non-local dependencies like WH movement? Okay, so here's the idea. This is, again, Laurel Perkins' idea. So we have gap-driven learning. The infant uses argument structure to trigger the acquisition of movement dependencies. That's the basic idea. Let's see how. So first, the child is able to identify the argument structure of some frequent verbs. We've just shown you how to do that, right? So they do that by attending to the distributions and also thinking that some of the data they're exposed to is noise. Second, they have to notice when arguments of a verb that they think are transitive are unexpectedly missing. Now we know they can do that because we've seen that at 15 months, that's the ability to see that a verb is missing one of its arguments that underwrites their apparent understanding of WH questions prior to having acquired the grammar of WH movement. And then third, and this is the thing we'll focus on, is they can identify the surface forms that correlate with unexpectedly missing arguments. So for example, you can imagine a learner which clusters sentences based on surface properties that they have in common and use those clusters to figure out which sentences contain argument gaps and hence which ones have movement in them. So suppose you have these sentences, which are all alike in the respect that they have these weird function words that the child doesn't yet know. That's the blue things on the left edge. And they have an aux before the subject, right? And some of these sentences have unexpected transitivity violations, and the remainder have verbs which have alternating transitivity. So if the child then can generalize those unexpected arguments to the rest of the members of the category, right, then they can infer that this is a category of sentences that involve movement. And in particular, that the signature of movement is these particular kinds of WH words on the left edge of the clause, right? So the WH phrases are the surface signature of movement, and you can detect that there's movement because you have this prevalence of verbs in the category which are missing their arguments. Okay, and a computational implementation of this model does significantly better than chance at forming the relevant categories of sentences that have movement. Let's not go into the details because it looks like I've spent a whole bunch of my time here. Okay, so here's a kind of sum up of what we've seen so far. So inside the language acquisition device, we have to be sensitive to the perceptual intake properties. That is, what is it that the child perceives that they're able to learn from? And that perceptual intake can be distorted by lexical frequencies, and it can lead to errors in learning, but it also, on the positive side, feeds new discoveries about the target language. So can be distorted in the case of learning the argument structure, but then it can feed new discoveries in the case of WH movement. Second, there's an additional portion of intake filtering that happens, not because of language external properties like how parsing and extralinguistic systems interact with the grammar, but also because of how the grammar learning mechanism itself behaves. So we've seen that the acquisitional intake can filter out non-basic clauses in order to acquire transitivity categories. And then having acquired those transitivity categories, that can then be used to feed forward to identify the surface features of WH movement in the language. Finally, what kind of just stepping way back, what we've seen is that linguistic perception changes over development, and that our model of language acquisition has to take those changes into perception into account, right? Because those perceptual properties feed subsequent learning. And finally, learning is best understood as identifying abstract structure in surface form, not merely capturing the distributional properties. In the case of WH movement, what we've seen is that knowing that there should be something like movement allows you to recognize that this category of sentences that are alike in some surface way also are alike in having these argument dependencies in them. Okay. So that's it. Many thanks to all the people who did the hard work here, and I look forward to hearing your questions.
Okay, thank you, Jeffrey. I'm just looking to see, invite people to make questions and comments about Jeffrey's talk. Please put on our YouTube channel. Let's just quickly see if there's something coming up. So I do have some questions of my own interest, Jeffrey, while we wait for the others to ask you stuff. It's just the question, when you presented about Laurel sequential listening preference procedures, I was just in terms of research, like how do you collect that data? Like, because I saw that you're using the visual, like the kids looking into it, but is there any other, like, do you guys, I don't know, have categories to what you look and how you observe this to get in terms of research and collecting data? Is there any other procedure behind it when the kid is looking to the TV?
Well, no, it's actually pretty simple. So the babies are sitting on their parents' lap usually, or sometimes in a high chair, and they're watching the video. And basically, we just have a camera trained on them, and we have somebody in the other room who can't hear the audio, who just pushes a button when the child is looking at the screen and pushes a different button when the child is looking away from the screen. And we just take those observations when they're looking, when they're not looking, and get a measure of how long they listened. So it's a very simple measure.
Okay, great. Because we do have some departments working with multimodal interpretation, and they create lots of categories to look into how the person moves and the eyebrow movement and stuff. But I think for youngers, for really little toddlers, it's kind of more complicated. It's just more into looked and not looked. Yes. Let's see if you have something here. And another thing that you put in one of your paper in terms of mapping out the development trajectories. And all my questions will be about research with our lab here in Rio. Was just thinking of how you also, again, if you have any ideas on how you collect data in terms of trajectories from one specific time and how you move forward collecting that data, is because one of your, I was reading some stuff about your lab that say you use lots of a broad set of tools to collect data. And I was just thinking if in terms of getting the trajectory, because as you also said here, that's how the data changes, throughout this time. Is there any way you guys map out this trajectory that
well,
I don't know.
I think, the trick in language acquisition research is to get data from a lot of babies and to get data at lots of different time points. We don't generally do like longitudinal studies. We don't follow particular kids across time, but we do get lots of cross-sectional data at different age ranges. And then once we have those patterns, then we can try and make theories of how that trajectory unfolds.
Okay, great. Just see if there's something up here. I think that's it. Jeff, we would like very much thank you for coming. It's not physically, but digitally. Next time, probably physically, to have more interaction with us here in Brazil. Thank you a lot.
All right. Thank you. Bye-bye.
Bye.